And welcome back, and we're on to the Corbett 5 a day for further maths, and let's have a look at the first question. Right, so it's obviously a circle theorems question. It is one of those whereby it's easy to get it wrong if you jump in too quickly. The point of this question is the circle theorem you might be thinking of is the angle at the circumference is twice the area at the centre, but that angle there goes to this angle here. So there's a few ways I can do it. So I can either say that x plus 54 divided by 2 is this angle here, and then this angle plus 2x equals 180. Absolutely fine. Or I can do it the way around, where I can work out this angle here, which is called the reflex angle, and I can say 360 minus x plus 54 is equal to, well, it's equal to twice the angle, sorry, screen moving, is equal to twice the angle of the circumference, which is 2x. Which means, now do this carefully, so 360 minus x minus 54 is going to be 306 minus x is equal to 4x. Add x to both sides, which means 306 is equal to 5x, which means that x is equal to 61.2 degrees. Nice question. Quite enjoyed that one. Next one. Okay, so this is one of these questions whereby you can just do too much here. You need to think carefully about what you're trying to do. So it says a coefficient of x squared in the expansion of. Now, having said that, I would be careful of trying to be too clever here. And the reason I say that is because if it said the coefficient of x to the 0, in other words, constants this, you would just have to care about the constants. If it said the coefficient of x cubed, you just have to care about the x cubed numbers. This one's slightly trickier in the fact I care about x squared. So having said, let's see if we can find a quick way of doing it. I'm actually just going to expand because I think it's safer. So if I expand these two brackets here, that's going to give me x squared plus 3 plus cx plus 3c, and I'm going to multiply that by 5x minus 2. At this point, I am going to think about what I care about. I only care about things that are going to give me x squared. So this times this gives me x squared, and this times this gives me x squared. So in other words, I can say that 5 times 3 plus c plus minus 2 times 1 must be equal to minus 17. In other words, I've only cared about the things that expand to give me x squared. 5 times 3 is 15, plus 5 times c minus 2 is equal to minus 17. 15 minus 2 is 13. Take away 30 from both sides gives me minus 30 is equal to 5c, which means that c is equal to minus 6. What a deceptively difficult question, but a good question. Next question. Right, as soon as it has exact value, I'm thinking it's going to be some nice sine numbers like sine 30 or sine 60. And indeed, if I now look at the diagram, I can see I've got a sine 60. It is also the sine rule. So there's my opposite and there's my opposite. So therefore it is the case that sine x over 10 is equal to sine 60 over 16, which means that, what does it want to want? The exact value of sine x, so not x itself. So sine x is equal to 10 sine 60, which is root 3 over 2, divided by 16, and then I just need to clear this mess up, don't I? So 10 divided by 2 is 5, 5 over 16 doesn't simplify, so therefore it's just 5 root 3 over 16, and that is my answer. Good question. Oh, that's a pretty difficult question, that one, but well done if you got that one. Final question today. The curve C has equation, gives me an equation. The point P has coordinates, gives me a point. Another point on C also lies, and here we go. Another point also lies on the curve. The tangent to C at Q is parallel to the tangent to C at P. In other words, the gradients are the same. Find the x coordinate of Q. Right, okay. Firstly, I'm going to differentiate. And that's going to give me a quadratic, which is why I have two solutions. So if I bring down the 3, the third goes away, which gives me x squared minus 4x minus 10. So that is my, well, the 10 slightly neater, that is my gradient equation. Then I know at the point minus 3, so at minus 3, the gradient dy dx is equal to, well, minus 3 squared is 9, minus 4 times minus 3 is plus 12, and minus 10. So 9 plus 12 is going to give me 21, minus 10 is going to give me 11. Okay, how has that helped me? Well, I know I need the other point Q, which has the same gradient. So I want my gradient function, x squared minus 4x minus 10, to equal to 11. which is going to be x squared minus 4x minus 21 equals 0, which is going to be, well, 21 is 7 and 3, so it's going to be x minus 7, x plus 3, which implies that x is equal to 7 or minus 3. Now, whilst it looks like we have two answers, obviously one of those answers we already have the minus 3 from the question, so therefore it must be the case that x is going to be equal to 7. What does the question want me to do? So the question wants me to find the x coordinate of Q. So actually I don't need the y, do I? I just need the x. So therefore my answer is that x is going to be 7. And again, that's just for the Q coordinates. And that is it. That is today's final question done. Good mix of questions today, as ever. That second question was particularly difficult, although there is a quicker way of doing it. And that last question, sort of clever little mix of coordinate geometry. As ever, let me know how you did. Do like and subscribe, and I'll see you for tomorrow's. Thanks all.